Welcome to chapter 3 of section 2. So actually the last video ended shortly, ended too soon, but I just wanted to, the issue was I just didn't put the keyword public, but that was about it. Everything else was correct, and because I ignored this sentence. But yeah, let's move on. Chapter 3, msg.sender. So now that we have our mappings to keep track of who owns a zombie, we'll want to update the create zombie method to use them. So in order to do this, we need to use something called msg.sender. So in Solidity, there are certain global variables that are available to all functions. One of these is msg.sender, which refers to the address of the person or smart contract who called the current function. In Solidity, function execution always needs to start with an external caller. Contract will just sit on the blockchain doing nothing until someone calls one of its functions. So there is always going to be a msg.sender. So it's pretty much the person or the smart contract that is calling this function. And like this paragraph says, there always will be a value here because contracts don't just call itself. Ethereum smart contracts sit on Ethereum network and they wait for it to be called by either a person, which is a regular wallet address, or a other smart contract. So here's an example of using msg.sender and updating a mapping. So mapping, favorite number, which is the address key, value is uint, function set my number. So when this is called, they set number in the favorite number for the message sender. So what this line is doing, if you call this right now and you send your favorite number is 9, it's going to store that and it knows your address because you called it. So if your address is something that ends in whatever, that's going to be right here as the key. And then this is going to be the value. So it just stored your 9 at your address in this mapping. So what is my number? So this is how we retrieve it. So we're going to return mapping of your address, which is going to return this, which is going to return the uint. So in this trivial example, anyone could call set my number and store a uint in our contract, which should be tied to their address. Then when they called what is my number, they would be returned the uint that they stored. Using msg.sender gives you the security of the Ethereum blockchain. The only way someone can modify someone else's data would be to steal the private key associated with their Ethereum address. Now let's put it to the test. Update our create zombie method from lesson 1 to assign ownership of the zombie to whoever called the function. All right, so we have the create zombie. Do we have a mapping? Yes, we do. So we have the ID here. Let's update our zombie to owner mapping. Store msg.sender under that ID. So we have the ID. We want to store this address of the person calling. So we have a mapping now, zombie to owner. We know the ID of it. And now we want to store in here, we want to store the address correlated to this ID. Now, second, let's increase owner zombie count for this msg.sender. So this is going to tell you how many this address owns. Msg.sender. Just do a plus plus, yeah. So owner zombie count of this address is going to be a uint. So at the beginning, I'm assuming that's a 0. Yeah, because it starts at 0, and then we do a plus plus, and it increments. And there you go.